In this video, I want to try to figure out the transformation of the derivative. So we know the transform of f of t is equal to capital F of s. What is the transformation of f prime of t? Well, let's try to figure this out. The transformation of f prime of t is going to be equal to the integral from 0 to infinity e to the minus st times f prime of t dt. And for this, we're going to use integration by parts. I'm going to let u be equal to e to the minus st. Therefore, du will be equal to minus s e to the minus st. dv, I'm going to let that be f prime of t dt. So v is going to be f of t. I'm missing a dt here. So when I translate this, we have u times v. So e to the minus st f of t minus the integral of v du. So I have a minus the integral and a minus in the du. So I'm going to make this plus. And I'm going to go ahead and pull out the s. E to the minus ft f of t dt. And this integral here is still going to go from 0 to infinity, and we also need to evaluate this piece here from 0 to infinity. So this first piece here is going to be the limit as capital N goes to infinity of e to the minus sn f of n. We then need to subtract when we plug in 0, which will just give us f of 0, since this term here will go to 1. We needed to add s times this integral here, which is the Laplace transform of f of t by definition. So this is capital F of s. This e to the minus sn as n goes to infinity is going to go to 0. So rewriting this, I have s times f of s minus f of 0. So what we have is that the transform of the derivative of t is s times the transform of f of t minus our initial condition. And we can expand this idea to second derivatives as well. Let's suppose I have this differential equation, y double prime plus 6y prime plus 3y equal to 4 cosine t, and I have my two initial conditions. And I want to transform this. I'm going to suppose the transform of y of t is equal to capital Y of s. This is what I don't know. This is what I'm trying to find in solving these differential equations. So now I want to find the transform of y prime of t. Like I just discussed, this is going to be s times the transform of y minus y of 0. So for this one, s times y of s minus 2. And we can do the same idea for the second derivative. The second derivative will be s times the transform of the first derivative, since we need to go down 1, minus y prime, minus my second initial condition. Simplifying this gives me s squared ys minus 2s minus 1. And we can expand this idea to higher derivatives as well. Let's do another one, and this time I actually want to transform this entire differential equation. Once again, we're going to suppose the transform of little y is equal to capital Y of s, and this is something we will assume. The first derivative is then s times the transform of y minus y0, which is 2. The second derivative is going to be s squared ys minus 2s, so I multiplied the first derivative transform by s, and then I need to subtract y prime of 0, which is 3. So when I rewrite this, I have s squared y of s minus 2s minus 3. So this whole thing here will be y double prime. I then have a plus 3y prime, so plus 3 sys minus 6. That will correspond to the plus 3y prime. We then need to add y of s to correspond to the plus y. And it was originally equal to 4. So we need to find the transform of 4. We know the transform of 1 is 1 over s, so the transform of 4 will be 4 over s. So now I've transformed this entire differential equation. And it's going to be helpful to rewrite this slightly by factoring out a y of s. We have 3 terms that contain a y of s. The coefficients are s squared plus 3s plus 1. Then we're then left with a minus 2s, and then plus 3 minus 6 is minus 3, equal to 4 over s. I can also use the idea of the transformation of the derivative to talk about things like the transform of cosine when I know sine, so actually thinking about derivative functions. We know the derivative of sine bt is equal to b times cosine bt. Therefore, when we take the Laplace transform of b cosine bt, the actual derivative, we will get s times the transform of the original function, which was sine, so b over s squared plus b squared, minus the initial condition, which we get to ignore when we're talking about general functions. So therefore, I have that the transform of cosine bt, I need to divide this thing by b to cancel out the b here, and I would have an s over s squared plus b squared.